Question 6. Two air streams are mixed together in the air handling unit, AHU. First flow comes in at 1800 CFM of return air at 75 Fahrenheit and 50% relative humidity. Second stream of 700 CFM of outside air at 95 Fahrenheit and 60% relative humidity at atmospheric pressure. What is relative humidity and enthalpy of the resulting mixture? So we need to pull up our psychrometric chart. And one thing to note, this is at sea level. So our first condition is 75. So our dry bulb temperature is 75 degrees Fahrenheit, and our relative humidity is 50%. This is return air. And for the outside air, dry bulb temperature is 75 and 95 degrees Fahrenheit and 60% relative humidity. And this is for the outside air. Now, in your air handler, what typically happens, you have outside air that comes in. It mixes with your return air at this point, and then this goes into your space. This is your supply air. So this is our space. What happens in the space, then you have this return air that comes out. And you have exhaust air. So in the problem, we only have return air and outside air that mixes, and we have new supply air flow. So what happens, since we have 1800 CFM that comes in from return, and you have 700 CFM that comes from the outside, that gives us 2500 CFM. And for air mixing, you have to utilize fractions to find your new space condition. So I'll give you an example. Here, our outside air mixture fraction would be 700 over 2500. That's going to give us roughly 28%. And our return air fraction is going to be 1800 over 2500. That's going to give us roughly 72% fraction. From these conditions, we can find enthalpy and temperature. So to find enthalpies, we take our points, 75 dry bulb and 50 relative humidity. So that puts us about roughly here. Then we interpret that and find our enthalpy. And we do the same for our outside air, which was 95 degrees outside temperature and 60% relative humidity, and we find enthalpy here. So for our outside air, our enthalpy was 46.5 BTU per pound of dry air. And for our return air, it was 28 BTU per pound of dry air. So our final condition for the mixed air is going to be 32 0.2 BTU per pound of dry air. So this is one of the solutions we were looking for. Now for the relative humidity, we'll have to do one more interpretation. So we'll have to find what would be our final temperature condition. So our outside air was 95 degrees Fahrenheit, and our return air was 75 degrees Fahrenheit. That's going to give us a temperature of mixed air of 80.6 degrees Fahrenheit. Now, if we go back here on this chart and we look at, let's just say, roughly 81 degrees with 33 enthalpy, and we find our intersection somewhere here. So I would just say roughly based on those two conditions, our final relative humidity is going to be 57%, and this would give us final condition for our solution.